Now corresponding to question, first of all to the question, a block of mass m are released from rest. A block of mass m released from rest, here like that one, that one, that one, that one. Okay, they slide down the inclined surface as shown in figure A to D. A, here B, here C, and here D, so that the work done by frictional force on the block are same in all cases. Okay, our motto, we have focus on frictional force. Here frictional force, because block is moving on downward, this block also, this block also, this block also. So we have focus on work done by frictional force. Frictional force means here this frictional force, due to frictional force, what about work done in this case, in this case, in this case? Corresponding question is same or different. Okay, so we have check. How can check? First of all, we have focus on one by one. Okay, so first we have case, taking case first. In case first, make free body diagram of that block. Okay, this is M block, mg downward. Okay, mg downward like that one, mg here, suppose that angle theta, if this one is theta, this is also theta. Okay, so mg component here, mg cos theta, and here mg sin theta. Here normal component n1 this will equal to mg cos theta. Okay, and I know that frictional force, that is frictional force Fr. Okay, Fr is this will equal to mu into n1. N1 is mg cos theta, so Fr is mu mg cos theta. Clear or not? Because Fr is mu into n1, that's why. So we have focus on our motto, frictional force direction upward, but block is going on downward, so angle between these two 180 degree. So work done by frictional force on the block, frictional force here, this block is going on downward, so angle between these two 180 degree. So here f, this, if this distance is d, fd cos 180, cos 180 is -1, so it is written as mu n1 into d minus 1. So it is written as mu n1 into d. Okay, and put n1 value mg cos theta. Okay, I know that d cos theta, if this angle is theta, here L and here D, so L this be equal to cos theta, this be equal to L by D, so L this be equal to D cos theta. Clear? So you can say that if put here, put this value is L simply. So you got work done by frictional force on the block is minus mu mg into L. Clear or not? In case first. Now check in case second. In case second, here case second, block is given like that one. Okay, if you suppose in between here divided two part, A to C and after that C to B. Okay, first of all make in between, if block lie between A to C, then make the free body diagram. Here n1, here mg, so mg cos theta, if theta 2, that is theta 2, here frictional force, and here mg sin theta 2. Okay, so in this duration, frictional force upward direction, and but this one is going on downward. So whatever work done by frictional force, on the block in this duration, it is written as mu into n1. Okay, mu n1, here frictional force mu into n1, so mu into n1, what about distance, that is this distance is d2, so d2, and what about this one is going on downward, so angle between these two is 180, so cos 180 minus 1. Clear or not? Similarly, in between, if this block going on b to c, then make free body diagram. Here n2. Okay, and here mg sin theta 1, mg cos theta 1, because this one is theta 1, that's why here mg sin theta 1, frictional force in this direction, and block going on here, so angle between these two 180 again. Okay, so work done during C to B. It is written as mu into N2 into D2. This distance is D1, sorry, D1. So D1. So mu mg cos theta 1 into D1. D1 cos theta, if common, mu into mg is common. So what about this one? This one is L, simply L. Because of this one is d cos theta 1, here d2 cos theta 1, theta 2, and here d2 d1 cos theta 1. So sum of these two, that is L. Put here and we got same value minus mu mg into L in case second. Okay, now we have discussed case third. Case third, this one. You focus on that one. In this duration N1, frictional force here. If N2, frictional force here. If N3, this frictional force here. So work done by frictional force on the block is written as mu1 into N1 into what about this distance? This is D1, here D2, and that is in D2, here D3. So mu1 N1 into D1 to cos theta 180 because of block is going frictional force upward and block is going on downward. Okay, so angle between these two 180. That's why. Similarly here 180 180 cos minus 1, so minus 1 is common. After the mu mg is common, so d1 cos theta 1, d2 cos theta, dt3 cos theta 3. Okay, this is d1, this is d2, this is d3. This one is d1 cos theta 1, this one is d2 cos theta 2, and this one is d3 cos theta 3. Sum of these three we got L. So that is minus mu mg L. In these three cases, frictional force due to frictional force, work done by frictional force is minus mu mg L in these three cases. Now we have discussed last case, force 4. This is the curved surface. In this case, this is the curved surface. Okay, so you can consider very small strip in very small. If this angle is theta, so here mg cos theta, here n, frictional force mu into n. Okay, so work done by this frictional force and block is going on downward, here mu into n, that is frictional force, and here this block is going on downward. Okay, this is ds. So work done by frictional force for very small ds distance, work done by frictional force over ds distance, it is dw is equal to mu into n ds cos 180, because 180, that's why it is written minus mu mg cos theta into ds. So but this block is going on a to b, a to b, a to b, so it is written a to b mg cos theta ds. I know that here dx, here dy, and here dx, that is theta. This one is theta and that is ds. Okay, so ds is cos dx is this equal to ds cos theta. So what about this value? That is dx, simply dx. A to b, a to b, what about ds? That is L. So that is minus mu mgl. So you can say that calculations show that the work done by the frictional force in each case are same. Clear or not? This is the final answer. If any doubt, then write now in comment. I will decide. I will discuss again. Okay, make it. Thank you.